In the previous lessons, we have learned what are acids. And acids are those substances that give out hydrogen ions. And bases are those substances when on addition of water give out OH ions, or the hydroxide ions. So again, we call them as hydrogen ions or hydronium ions, and bases give out OH ions or hydroxide ions. Now examples of acids we learnt as HCl, sulfuric acid, bases, NaOH, calcium hydroxide, and so on. They're all called bases because they give out the OH ions. Then we learnt what you mean by strong acid or a strong base. A strong acid or a strong base which gives out large number of ions. Large number of hydrogen ions in the case of an acid and OH ions in the case of a base. And when we talk about a weak acid or a weak base, means it gives less hydrogen, less number of hydrogen ions and OH ions. Thus HCl is considered to be a strong acid. Why is it a strong acid? Because that almost all the molecules break down to give hydrogen and chlorine. But when we go to acetic acid, which is C3OOH, this is acetic acid, we call this a weak acid. And why do we call it a weak acid? Because this gives a few ions of OH, few hydrogen. All the molecules do not break up to give acetic acid, the acetate ions and the hydrogen ions. So we know we have strong acids and we have weak acids. We have strong bases and we have weak bases. So we need a scale to measure how strong an acid is, how weak a base is, or how weak an acid is. To compare acids and bases, we need a scale, and that scale is called the pH scale. This pH scale helps us to measure the strength of an acid or a base. So a pH scale here I have drawn right up from 0 to 14. Somewhere in the middle will be 7. Now the substances that are acidic are between 0 and 7. Between 0 and 7. On this sides we have the acids, and on the other sides from between 7 and 14 we have the bases. Now those which are on the acidic side, here in this acid side, in all these cases the number of hydrogen ions are greater than the OH ions. And when we come to the bases side here, in this case we have the OH ions will be greater than the hydrogen ions. Now this is a picture given in your textbook on page 25, and let us see what it says. Number 1, the pH scale starts at 0 and it ends at 14. And in the middle here is 7, where everything is neutral. pH 7, we'll make a point here, pH 7 means neutral. And now they have here colored this. See this, what does this mean here? In this region, have you seen this is blue here? In this region, this is the hydrogen ion concentration. Here is the hydrogen ion. So in all this area, have you seen the number of hydrogen ions is more than the number of OH ions. But when we go on to the other side here, on the other side here, what is happening to the hydrogen ions? They are slowly decreasing. This is here hydrogen ions, and this here are the OH ions. So when we go on to the other side, we find that the hydrogen ions are now becoming less than the OH ions, and we get bases, or we get basic nature. In the first part, Here the OH ions. Here in this we have the hydrogen ions are much more than the OH ions, and these are all acids. And as we move more towards 0, the acidic nature keeps on increasing. And as we move more towards 14, the basic nature keeps on increasing. Which means if suppose I have 3 solutions. I have a solution A, and I have a solution B, and a solution C. Suppose the pH of A, say, is 2, and pH of B is 5, and pH of C is 1. Which would be most basic? To start with, these are not acidic. These are all pH 2, 5 and 1. These are all acids. Why are they all acids? Why all these are acids? Why are they acids? Because they all have pH less than 7. So they are all acids. But who's most acidic here? C will be most acidic, because C most acidic will be C. It has got the least pH. So if I were to draw the pH here, the pH scale, this is 0, this is 14. Your A would be somewhere here. I'll mark this. So my A will be here, this will be A, this will be C, and this will be B. And here the acidic character increases on this side. So whose most acidic will be? C. Who will be least acidic? Will be B. Now here again I'm giving you 3 solutions. P has pH 6, Q has pH 12, and R has pH 8. They all have pH more than, all of them have pH more than 7. So they're all basic. But who is most basic? Now to find who's most basic, I'll draw the pH scale again. So the 0 to 14. So since this is basic, I've drawn only the basic scale. I've not drawn the acidic one. So pH 6 would be somewhere here. I need to change it to pH 10 because pH 6 would be acidic. We are dealing all with bases. So I make P as pH 10. So my P would be here. This would be P. Q is 12. So it would be here. Q would be here. And R is 8. So R would be here. Now who would be most basic? And who would be the least basic? Now remember, the basic character increases. The basic character increases, which means as we go down from 7 to 14, the basic character increases. So who will be the most basic? You'll definitely agree Q with pH 12 will be the most basic, and least basic will be R with pH 8. We will learn now what is an universal indicator and why do we need to use it. Now when we use a red litmus or a blue litmus paper, we only know if a substance is acidic or basic. It does not tell us the pH. It does not tell us is it a strong acid or is it a weak acid. If it is acidic, the blue turns red. The blue will turn red in HCl. The blue will turn red also in acetic acid, in a weak acid as well as a strong acid. So litmus paper does not tell us exact pH. However, universal indicator tells us the exact pH. Here is a strip of the universal indicator. It is a strip of paper that is dipped in the universal indicator, and it shows different colors for different pH. Look up here. In the first case, for gastric juice, which pH is about 1.2, which is quite high, it shows a red color. Then for lemon juice, it shows a lighter orange color. For pure water, it shows greenish color. Then a milk of magnesia, a little darker, and it goes on. So the universal indicator, this is in your notebook, in your textbook, it shows different colors for different pH. So it gives us more information. Now, how is this universal indicator made? This universal indicator is a mixture of many indicators. It's a mixture of several indicators. And the very important part, or the advantage of it, it gives different colors for different pH. Different colors for different pH. So by using the universal indicator, you can exactly tell the pH of that substance.